Hello everyone, and welcome back to our video review series for the review for the AP Stats exam. This video today, we're starting off talking about t-intervals now. Previous unit was all about proportions. This unit is going to be all about means. So it's going to be our t-intervals, our t-tests. We'll talk about the difference between one sample, two sample, matched pairs, all the good stuff that's really important. So let's jump right into it here. The big idea, again, with confidence intervals is that we're going to take a representative sample and then we're going to cast a net in either direction. Now, when we cast that net, the hope is that we capture the population parameter. Now, I tried to show this video or this demonstration before, and this time it's actually going to work. So the idea here is this gray dotted line is our population. The red dotted line is our sampling distribution. And so the idea here is if I take one sample, all those yellow dots represent the sample data points. The black dot represents the sample mean, and those bars that are coming off of the side of that represent the confidence interval. And so in this case, right, this green vertical line is our population mean. In this case, we got it. Same here, same here. But it's not perfect. If I continue to do this, you will see that eventually at some point, I will miss it. Because if I take a look at this one particular sample, you'll notice most of my sample data ended up being on the right side of the mean. And that happens sometimes. We can't control that. Even if we have a random sample and everything else is perfect, sometimes this is going to happen. Same thing with this one. If you notice, most of your sample data is on the left side of the mean. And so they're not perfect. But as we know, the confidence level corresponds to the percentage of intervals in the long run that will contain what I'm looking for. So if I spam this for a while, you'll see this was a 95% confidence interval. We ended up with 95% of our intervals at this point containing it. Again, I could sit here for forever and click sample 25 until the end of time. That number would level out at around 95% each and every time. So going back to here now, a one sample t-interval is used when we're trying to construct an interval for the population mean, and most importantly, when our standard deviation is unknown. I'm sorry for the noise in the background. That is my dog coming down the stairs. Most importantly, though, here is when we do not know the standard deviation. This is really, really important. Now, granted, on the AP exam, you're almost never going to know the population standard deviation. The only time that might pop up is something like a question 6. So if you're getting a standard question 1 through 5 on the FRQ section, it's going to be a t-interval 99.9% of the time. And now again, our acronym for panic, right? Our parameter now is now a mu instead of a p. It's the true mean something. Insert the context. Our assumptions, I need a random sample. And for the central limit theorem, I need n to be greater than or equal to 30 or no skewness or outliers in my sample. That's also very important. The other thing you may see is you may see a sentence that says that you can assume that the condition for normality is met. And if you see that, that is also perfectly fine. For my numbers, I'm going to list my x bar, which is my sample mean. S is my sample standard deviation, and then my confidence level. The interval is a one sample t-interval. And now one thing I forgot to mention beforehand in your numbers is now with t-intervals, we also get this important thing called degrees of freedom. and that is equal to your sample size minus 1. Now, it doesn't matter where you write the degrees of freedom. Whether you write it in the number section or you write it in the interval section, it just needs to show up somewhere. So I can say that I have 28 degrees of freedom in the numbers section, or I can say a one sample t interval with 28 degrees of freedom. Either one is fine. And my conclusion stays the same as before, meaning it's the we are blank % confident that the true mean lies on this interval. So let's take a look at an example here. This question is from 2013. This is a question that was on one of your weekly assignments. But I think it's a great question to kind of demonstrate what you may see on the exam. So this was the very first question on the exam. So you're given the mean lead level of 23 crows. The first thing I notice is that there's only 23. So I know my sample size isn't big enough, so I'm going to need to use that no skewness and no outliers, or I'm going to have to look for that sentence that says we can assume the population is normal. Problem is, I don't see that. And so I know I'm going to have to use the no skewness and no outliers deal. So for here, my panic, this mu is the true mean lead level in crows in the region. I'm going to be specific here. You have to be as specific as you can. For my assumptions, 1, I need a random sample. Now, I did cut off the part of the problem that said that this was a random sample because I wanted to make sure I included the stem plot here for you and I didn't have enough space. The problem here did state that it was a random sample. One thing that is important is that if you are being asked to construct an interval or to perform a hypothesis test, you can do it. 100% you can do it. They are not going to try and trick you and say, hey, make this interval. But in fact, you can't make the interval. And now for the second one, my n equals 23. So what I need is no skewness or outliers. What I have here is a stem plot. And looking at the stem plot, there does not appear to be any obvious outliers. So based on the stem plot, I'm good. Now the other thing you could do here is you could make a box plot if you were given the raw data like you were here. But if you're already given a graphical display, use what you're given. You are given it for a reason. And so now for my numbers, my X bar was 4.9. My standard deviation was 1.12. The confidence level was 0.95. And my degrees of freedom here is going to be 22, n minus 1. My interval is a one sample t interval. And I believe, if I remember the scoring guidelines correctly, this was from about 4.4 to 5.4. I may be slightly off on that and remembering from the scoring guidelines. But for my conclusion, now it stays the same, right? We are 95% confident that the true mean lead level in crows in this region lies on 4.4 to 5.4. So I hope that was helpful for your review of a one sample t interval, and I'll see you guys in the next one. Bye.